Let's learn about the operators of R programming language. There are several operators in R, and the ones that we will be learning today are arithmetic operators, logical or Boolean operators, relational or comparison operators, assignment operators, and also some other miscellaneous operators. Let's begin with arithmetic operators. So arithmetic operators are those which are used to accomplish arithmetic operations. And remember, we learned about two types of data types. They were scalar and they were vector. So we learned that scalar is a single value, so we can easily apply the arithmetic operator on these values, and you have done that in many other previous languages, many other languages that you are familiar with. But we learned that vector is not a single value, rather it is a sequence of values. For example, this. So how can we apply arithmetic operators on vectors? We can still do it, and we will learn in a while how to do it. Okay, so now let's start with arithmetic operators. So you are already familiar with plus operator, and it is used to add two values, for example, a plus b. And then you are familiar with minus, that is used to subtract b from a minus b. And then you are also familiar with static, that is used for multiplication, and we use it like this, a star or a star b, and that means a multiplied by b. And then we have the division operator, which is used like this. So it means to divide the first operand, which is a, with the second operand, which is b, right? Now let's learn some other operators. So for modulus in R, we have this operator. This is percentage sign. So we have two percentage sign in R for modulus. And how we use them is like this, a, and then percentage sign, again percentage sign, and then b. So this operator will give you the remainder of division from first operand with the second. And we also have another operator for quotient, and that is percentage sign, and then division sign, and then again percentage sign. This is the operator. And we can use it to find the quotient when a is divided by b. And obviously we write it like this, a percentage sign, division operator, percentage sign, and then b. And so I think you are familiar with remainder and quotient concept. So if you're not, let's quickly see it. So if this is, you're dividing it like this. So for example, let's say I have a value 7 and I'm going to divide it with 2. So 2 3s are 6, 2 into 3 equals to 6. So 2, I will write 3 here, and I will write 6 here. 2 into 3. So 2 into 3 is 6, and then when we subtract it, so 1 remains. Now this is my remainder, and this is my quotient. So this is what we are talking about. Now we have another operator, and that is a power operator. So for power, we have this hat symbol, and we use it like this. For example, a hat b. So a power b, right? We can use it like this. We have another operator for multiplication of matrices, and we will see it in a while. Let's see examples of these operators. So I think you can do it with scalar values, but it is a bit difficult or maybe new to you when you are performing these operations on a vector. So let's see the example of using these using these operators on a vector. One more thing, we have another operator for power as well, other than hat, and that is double static, this vector. So we can use it like this, this operator, and we can use it like this, a double static b. This is another operator for power. So both of these work the same way. Hat and double static, they both work the same way. Okay, now we are going to see different examples of arithmetic operations on vectors as well as matrices. So we will be seeing both of them. But before moving towards them, I want to show you some examples of scalars as well, so that it's clearer to you. So let's begin with the modulus operator. That was a bit different, right? So the examples we used was 7. So let's say 7 and double percentage sign and then 2. So the answer should be 1, right? This is the modulus 1. And we solved this on paper like this. So the remainder is 1 and quotient should be 3. And let's see the quotient now. So for quotient, we had another operator, and that was percentage sign, and then division sign, and then again percentage sign. Let's do that and see the answer. So yes, the answer is 3, right? Let's see the hat operator as well. So let's say I want to take power of 2 power 3. Let's do that. So 2 hat 3, the answer should be 8, and that is 8. And let's do it again with double static. So double static and again 3, and the answer is 8. Okay, now let's quickly move towards these operations on vectors. First of all, let's create 2 vectors. I'm going to clear my screen, and then let's create 2 vectors. X is equals to, I don't know, let's say 1, 7, and 3, enter, and then Y equals to, let's say 9, 4, and let's say 5, press enter. So we have these 2 vectors now, 1, 7, 3, and 9, 4, 5, and we can perform all the operations we want on them. For example, x plus y, we can do that, and the answer is this. Okay, now let's see how is it working. So let me zoom in a little bit so you can see it clearly. Okay, now this was the first one, the first vector, 1, 7, and 3. The second one was 9, 4, and 5. And the way it's working is 1 is added to 9, 7 is added to 4, and 3 is added to 5. So actually the operation is being performed element wise, right? So each element is added to the other element to the element of the other vector, same element of the other vector. So this is how it's going. And 7 is added to 4, 3 is added to 5. So each element is added to the same element of the other vector. So the operations are being performed element wise. And you can do all of these operations. For example, x minus y, and it will give you the same thing. So 1 is subtracted from 9. So the answer must be minus 8, and that is right. So, and so on. For example, x multiplied by y, or x divided by y. We can also do it like this, x divided by 2, for example. This is the answer, right? And let's use the power operator here. Let's see what happens in this case. So if I write x double static y, what happens then? Press enter. So what happened is each element of the first vector was elevated to the corresponding element of the second vector. Let's use the other 2 operators, which were modulus and quotient operators. Let's use them, and we can see that now first vector is divided with the second vector, and the remainder is being given as an output. And we can also use the other one, x, the quotient operator. Sorry. Now let's see these operations on matrices. Let's say we have 2 matrices S and T. Let's first of all create the first matrix. 1, 2, 6, and I'm going to define the rows as 2 and columns as 3. This is my first matrix, and let's make the second matrix like this, 8 to 13, and rows are the same and columns are same again. Okay, so if you want to display them to see if we have created the matrices the right way, let's see the output. So this is the first matrix, 1, 3, 5, 2, 4, 6, and let's see the output of second matrix, and it's this 8, 10, 12, 9, 11, 13. Or if you read it downwards, 8, 9, 10, 11, 12, 13. Anyway, now let's see if we add these 2 matrices, what will happen. How can we use arithmetic operations on these 2 matrices? So S plus T equals to, this is a new matrix. So what happened is 1 is added to 8, 3 is added to 10, 5 is added to 12, and that is the output. So what's happening is each element of first matrix is added to the corresponding element of the second matrix. So the operations are being performed element wise. That's very easy, it's not difficult. So similarly, you can perform other operations on them as well. So s minus t, and you can see the output. How is it minus 7 for every one? So yeah, every element is 7 elements, 7 numbers apart, every corresponding element. Anyway, we can also multiply it. So s static t. Now this will multiply the matrix element wise. That means 1 will be multiplied to 8, 3 to 10. This is not the proper famous matrix multiplication. This is just element wise multiplication. And we can see the answer here. Now if you want to perform the proper matrix multiplication, for that, first of all, we need to have the right dimensions, correct dimensions.